Hello, everyone. I am Dion Cook from AVIXA, and welcome to LED Video Walls, the invisible mechanics that bring picture into view. This is the first of a two-part webinar series presented by Todd McCandless with assistance from Alina Mishra. This webinar is brought to you by our sponsor today, Barco. This two-part series, the second part, will air live on April 22nd at 1 p.m. Eastern Standard Time. Before I hand the presentation over to Todd and Alina, I just need to go over a couple of quick housekeeping items. For everyone viewing today live, this webinar qualifies for one CTS, one CTS-D, and CTS-IRU. Please allow up to 7 business days for that renewal unit to appear on your transcripts. If you have any issues with this, please email my team at webinars@avixa.org. The webinar will be approximately 45 to 60 minutes long, and all attendees have been placed on mute. If you have any questions during this presentation, please enter them in the Q&A window so that today's moderator can address them at the end of the webinar. To get to the Q&A window, just move your cursor to the bottom of your live stream video box and locate the Q&A icon and type away. You will have access to this webinar on our website at avixa.org/webinars within about 5 to 7 business days. Now I'm sending it over to Todd and Alina. Please take it away.
All right, Dion, thank you so much for joining this presentation. Thanks for your kind consideration. My name is Todd McCandless. I'm the Director of LED Sales Support for the Americas for Barco. And today I want to talk to you a little bit about LED. In particular, I want to talk about what you don't see on an LED display that can make a lot of difference. So let's just jump in. First of all, why LED? For you veterans out there, you'll know why you use LED. You'll know the benefits, and certainly I'm sure you're aware of some of the challenges around LED. But for those of you that are newer to direct view LED, why LED? It's the only technology that really combines it all with incredibly strong colors, perfect contrast and brightnesses. It truly is a seamless display, or what we like to say is a single canvas in which to show your content on. And because of the modularity of the tiles, it really does lend itself to creative applications and displays. We're not restricted by that 55-inch diagonal, 70-inch diagonal. You can create whatever size display in whatever configuration, and you can see in those experience centers how important that is. It also has a shallow mounting depth, which is terrific, and a very wide viewing angle, up to around 160 on average degrees of viewing angle. So it is a terrific platform for content and has rapidly become a go-to visualization product. So the LED, where are we seeing LED? It's certainly in lobbies, experience centers. And really, if you think about the larger the display, the bigger the impact of the display is, it's critical to have great content for that. And in this application in a lobby, the AV designer and consultant did a fantastic job of creating some terrific content. We see a lot of LED in lobbies. In conference rooms, we see a lot of LED. The automotive industry really likes LED for their R&D labs to render full-size automobiles in their labs. Corporate theaters, this is a great application. And to give you an idea, every screen you're seeing on this picture is a massive LED display. And the bottom picture just shows you a little bit about the scope of this install with the people on stage and just how large those displays are. It's a wonderful application of LED. Corporate boardrooms using LED instead of projector, or a 3x3, 4x4 LCD array. And broadcast studios also using a lot of LED. It really adds an impact. And because of LED processing, we can match studio colors and set designs very effectively with LED. So broadcast studios, another emerging market for direct view LED. I want to talk just a little bit about the things you can see, the diodes themselves, and kind of the evolution. I won't get into the long grass on this. That will be for another conversation. But if you think about the beginning of LED with the the red, the blue, the green, you pull those through. They call that through-hole technology. You solder those off, and you're ready to go. That is kind of where it started. But the evolution has rapidly advanced to SMD. Black SMD, chip LED, chip on board, IMD, or 4-in-1s. These are all new technologies. And they're all really centered on how that chip placement is placed on the main circuit board. And this is just the evolution. If you go from top to bottom of this slide, it's really a march to higher resolution. And each one of these technologies, I must add this, they have great benefits, but they all have their challenges too, including chip on board. And the manufacturing process can be pretty complicated. So all of these technologies are part of what you're seeing on that display. Also, the size of the diodes themselves has gotten smaller and smaller and smaller. And with a smaller diode, we get better contrast, we get smaller pixel pitches. That's all great for high resolution image. But the more difficult, the smaller the diodes, the more difficult it is to manage or manufacture, and more costly to manufacture. I've seen some marketing saying that, you know, we have micro LEDs, but they're over 100 microns. Technically, that's really a mini LED, not a micro LED. But it is marching to a smaller and smaller technology in the LED world for sure. And then also, the LEDs, when they're actually manufactured, they manufacture these in batches, and all of those diodes share a particular performance characteristics with all of the others in that batch. This is a brightness index number. You may have heard this referred to as a bin or binning or batching. And this is an important part about direct view LED. If we were to replace a module with diodes from a completely different batch, there is a visual difference between that module and the rest of your display. And that you can iron some of those wrinkles out with software and brightness and color levels, and you can minimize it, but there is a visible difference between that. Now, if it was one single diode, not so much, but a full module, you start to notice those issues. There's a few ways around that. For us, we offer batch protection, which basically a new module that we would replace a defective module with, maybe 4 or 5 years into ownership. Well, that new module, the diodes on that module that we install came from the same batch as all the diodes on that existing display. And that really is just trying to achieve display uniformity. So as you look at display uniformity, you know, there's some ways to accommodate that. Maybe you buy more modules up front and have those in reserve for replacement to make sure that you have diodes from the same batch. But that's something certainly particular to look at. Now, certainly R&D labs at manufacturers, they're marching towards getting away from having this binning or this batch issue, and in time, I'm sure that they will achieve that. But as of now, that's just an element about the diodes. So let's talk about what you actually don't see on an LED display. The first place I want to start is image processing. And the important thing to know about this is that direct view LED doesn't process the display or the image in the same way that your active matrix LCD display at home would, or in a boardroom's conference room scenario. Direct view LED is a little different. And that's why it's absolutely essential that you get the processing nailed perfectly. Because if it isn't, you can run into some serious problems. The first thing I want to talk to you about is a complete signal ecosystem or a third-party manufacturer. If you consider that all of us were going to start a LED processing company that makes a black box for LED processing, that would be great, and we would make a black box. But in order to work with dozens upon dozens of different LED manufacturers, we'd have to make a few compromises in our system architecture to ensure that we work with multiple manufacturers. Now, that's okay, but those compromises are really where the devil lies. It's the devil in the detail, right? And one of those issues is really about having that synchronicity and controlling that entire signal flow to ensure the performance from the processor to the actual LED modules themselves is one system. Now, we've always chosen to manufacture our own LED processor, and there are some really good third-party processors as well. I'll give you an anecdotal tale. I was talking to an AV consultant not too long ago and said that he's done with third-party processors. The tale he told me was that when they updated the firmware of the LED processors, it killed the display because the LED drivers and the modules themselves didn't work well with this current version of the firmware. They updated the firmware because there was added features that they would like to have. So be very careful when you're looking at third-party and LED tiles, the quality of the LED tiles, the drivers they use, all of those things are critical to ensuring that you have this technology evolution path with the processor that will work in harmony with the tiles. Now, is that to say that all third-party processors are bad? Of course not. There are some nice third-party processors out there. It's not a path that Barco chose. We manufacture our own and always have, but there are some really nice third-party processors out there that do a good job. But it's important to do that homework and ensure that firmware upgrades from the processors will work with the tiles, the drivers in the receive cards that you're using. It's important to make sure that that ecosystem will evolve over time. Another thing that sometimes you'll see, the larger the LED display, the more processors you'll need. And those processors have to work in perfect sync with each other. When they don't, you can see image tearing. This is where the actual image tears in the center of the image as it's processing. Now, when I start this GIF on the right, if you watch the airplane fuselage, you'll see the actual image tear all the way down through the center of the image. And there it starts to tear. That's what image tearing looks like when two processors or more are out of sync with each other. And this is also a really important part about image processing, to ensure that they sync perfectly, that they work in harmony, and that you don't get image tearing. Another thing you might see is, if you're at a trade show, it's one thing to show a really high resolution image that looks stunning. That's awesome. But when you do full motion video, that's a different beast. And what you might see is image tearing, or sometimes even full motion video, the entire image will have a slight jitter to it for some reason, just slightly jittering the whole image. And that can be unnerving to the human eye if you're looking at it. So these are some of those artifacts that you can get when LED processing isn't syncing correctly or working correctly. Now, what you're looking at here is at a trade show. This is a major manufacturer of LED. And what you're supposed to be looking at is a night sky with stars. This white dot in the center, that is the only thing that should be lit up. But what unfortunately you're seeing are these green trailing lines. And the reason you're seeing that is because there's residual current hitting these LED diodes that are lighting them up briefly, and that's causing this issue. And the reason that is because the way they send power and data to the LED diodes is through a system they call banking. So we'll have X amount of diodes in one bank, and this is actually residual current that's lighting up those diodes and creating this effect. Now, while that may look reminiscent of a Matrix, an image out of the movie Matrix, and while that's cool to look at, this isn't cool, because this isn't what you want to see when you're truly showing just a white star. So this, again, another critical component of processing, and what happens when the processing and the LED modules themselves aren't working in perfect sync with each other, and the problems that that can cause. The other issue about LED processing is latency. This is critical because when you're syncing the video and the audio, and it has to be in perfect sync, this is a critical element for image processing. And pay particular close attention to the specifications, and certainly if you're getting a demo done, look at latency and really measure that latency if you can, and talk to that manufacturer about latency. Now, I have a little bit of personal pride in this next GIF. The display that's lit up on the far right of this image right now is the Barco display. All these displays are sent the same white flash at exactly the same time, and the video will start out in regular full motion, and then it will go to slow motion to show you the difference in latency. So when it slows down, you'll see our display lights up, and then the other display lights up. The latency is incredibly low on ours, and that's great for us. But I want to show you the difference in the different amounts of latency. Notice that there's one display that hasn't even lit up yet when ours has already completed the full flash cycle. That's how much latency you can experience in processing. So latency, and imagine, if you will, in your install, you're trying to sync audio and video. Maybe you've got a talking head on stage and you want to sync that. This is a critical element of image processing, is to reduce that latency. So keep your eye very closely peeled for image latency and processing. The next thing I want to talk about is low brightness and high details. When you run a LED display at 100% brightness, some systems have a tendency to wash out, like the lower left side of this picture. It will wash out. It will get kind of white and washed out in appearance. And on the flip side of that, when you run down to, let's say, 10% brightness, you start to lose a lot of detail. The black isn't rendering correctly. The dark images aren't rendering correctly. And you lose detail and you lose color. And that's a real issue for the brightness side of this. Here's a good example of a shootout. If you look over the top of the tire on this car at 10%, this is what it should look like. This is black. We render that black perfectly. But on the right-hand side, you'll see this area right here. This is called banding, or as some people jokingly refer to this as the Netflix effect. This is this black banding. It's almost as if the processing in the LED, they just basically gave up. They can't achieve that color bit depth level. They can't render that bit depth and show that black level and the detail in grayscale like others. So there is a real difference in LED processing, and this is part of it. Another example, this is at a trade show, but you'll see these areas that's being pointed at. There's these black banding areas where it just gave up. It can't render that black in that area. And this, again, another good example of image processing running at low brightness. You might ask, well, where would you run low brightness? Well, keep in mind that most LED displays aren't running at 100% brightness. An 800 nit LED display at 100% brightness can be overwhelming to the human eye. It's very bright. So most LED displays run in that 30 to 60% brightness range, depending on ambient light. And if you're in a control room with low ambient light, you don't need to be running that bright. But just know that as you step down in brightness, that image processing becomes essential to be able to reproduce the detail in the grayscale, and the black levels are critical for reproduction the lower in the brightness you go. Another thing I want to talk to you about is eye fatigue. The box on the left with the scrolling horizontal lines, that is typical of how most LED, direct view LED processing happens. That's how they render an image, and that's how they process the image. Now, in a command control environment, if you're looking at this for 8 hours a day, this will create serious eye fatigue. It's a real thing. And Barco addresses that through a patented algorithm that we scramble. That's the box on the right, but it does show you the difference. And the larger the display, the more apt you are to actually see this in action. If you look at a very large LED display and you sit there for a little bit and focus on it, you may be able to detect that scrolling horizontal bar processing. And over time, that creates eye fatigue. So we took a long look at that and solved for a lot of that in the way that we process that through a patent. But keep that in mind as you're looking at those long-term displays where people are going to be looking at it for any length of time. And the larger the display, the more impact that might have. But that is a product of how, as a passive matrix, how they process image in direct view LED. Next thing I want to talk to you about that you don't see is the mounting. And I'll be honest with you, this is sometimes the most complicated part of direct view LED. I wish, and I'm sure most of you do too, that LED was more like Legos. We could just snap them together and off to the races. But it's not that way. It's unfortunately not as simple as hanging a picture on a nail. It takes a lot of mechanics. Internally, we have a couple terms. We call it mechanics or steel work. Basically, that's just the mounting hardware and how it's mounted to the application. So let's talk about curved for a minute. That's usually a pretty common topic. There are companies that make curved and sort of a flexible tile, and that does happen. We used to make an 8mm and a 10mm. But with curved, it's all about the resolution. The higher resolution, the more difficult it is to curve. And to explain that a little bit is, when we say a 1.2mm pixel pitch, that means that it's 1.2 millimeters from one pixel to the next. In a concave, if you bend this too much, then that distance is greater than 1.2 millimeters. And in a convex, or in a concave, it's closer, I'm sorry. If in a concave, it's closer. When you compress those diodes, they become closer to than 1.2 millimeters. In a convex, they become farther apart than 1.2 millimeters. This creates a disparity of the human eye. When you look at that display, it doesn't look right. It creates a non sequitur for your brain. And that's why flexible, very high res is very, very complicated to do. So that's something to keep in mind when you start thinking about, well, we could just, bend those tiles. It's difficult to do. Now, there are some companies out that do make some semi-flexible LED tiles, and they do a great job of it. But as you get into this very high resolution, it's very complicated to do. Does that mean that we can't curve LED? Of course not. We can. And the way that traditionally right now you'll see is that the tiles will be installed, and then the next tile to it will be offset slightly, and the next one's offset slightly, and eventually you create a nice concave curve. It does present a little bit of faceting because those tiles are not curved, they're straight, but when the wall's lit up, you don't really notice that faceting. And it's really not discernible when you've got that display running at 60%. It is easier to do concave than convex. Imagine if we were bending or curving this display the other way. There's frames behind these modules, and you have to do something about those frames from touching each other behind this as you go convex. So it is easier to do a concave than convex. Some folks do convex, and they've got solutions for that, and it's terrific. But this is primarily how you're seeing LED curve now, and in this faceted approach. Also, corners add a level of complexity too. It's a recent install we did with a 90-degree corner surface to surface. Now, right here in this center picture, I'm showing you one of our frames, and each of our frames, the frame is 16 by 9, it includes two LED modules per frame to make one what we call an LED tile. Now this tile is matched up to the one coming from the other side of the wall, and they join here. The picture on the left is showing you the chamfering that we have to do to the frame to make those meet. Now what you're also seeing on the front of that is a standard module, not a chamfered module. So on a corner, even the module substrate and the module LED composite or board itself has to be chamfered in order to make that seamless corner connection right here. And this is just a good example of the type of detail behind the mounting required in order to do a corner like that. Again, I wish I could just hang these on a nail, but it doesn't work that way. It takes a nice mounting system to support that weight, that structure, and the accuracy for this corner. As you can imagine, in any of these installations, the X, Y, and Z axis is imperative for a corner installation like this to get straight. And I'll talk about X, Y, and Z in just a moment. Mounts can go wrong. There's a couple of things I want to point out about mounts. And I use these, I'm just being cheeky here, folks, but I'm using these images to kind of prove a point. This is a rental tile. These are obviously not what they wanted to happen. But the point I want to make here is weight. And weight of LED tiles can add up pretty quickly. And if you're not doing a remote power solution and the power modules are on the actual tiles themselves, this can get pretty weighty pretty quickly. So it's very important about where you're mounting that to have the sub and the backing capable of managing that amount of weight and that load and that structure. And so you got to pay particular close attention to that. The steel work that goes between the frames and goes on the wall is also a critical element, whether that's unistrut or custom milled steel work that you're using with tiebacks or stringers. That's really important to have that accurate and designed to hold the kind of load that you need to hold. Sometimes I've seen some installs where I'm pretty surprised that LED display is still hanging there on some pretty thin metal. So make sure that is addressed. The other issue is heat. For our tiles, 70% of the heat comes off the back of the tile. So you might say, well, that's what I love about LED. I can just suck that right up against the wall. Well, you got to be careful there because there's a lot of heat coming off the back of those tiles, and we have to do something to dissipate that heat. So it's important, and as you can expect, that the larger the display, the more heat that display is going to generate, and the more distance you'll need to dissipate that heat behind the module. And certainly most manufacturers have a calculation for heat loads based on display sizes, and they should be able to tell you the offset that you'll need from the wall in order to get accurate or effective airflow behind that display to keep that display cool. Now, I know all of you work in a world with perfectly straight and plumb walls, but occasionally at Barco, we find applications that don't have that, and it's critical to get the alignment straight. The first thing I want to mention about high resolution fixed install LED is that the tolerances we're dealing with can be the thickness of a piece of paper or human hair, depending on how narrow pixel pitch it is. If you're dealing with a 0.9, it is absolutely essential to get that first tile correct and start building and getting those X, Y, and Z axis alignments perfect. Because if you don't, that first tile, then the second tile has some tolerance, third more tolerance, fourth more tolerance. By the time you get to the end, you're going to spend a tremendous amount of time now going back trying to adjust X, Y, and Z axis and trying to manipulate. It's a tedious exercise, and it's very difficult to do. And sometimes you have to take tiles back out and reinstall. So it's critical to get all of those alignments perfect. The higher the resolution, the more critical it is. This is just a great example. This is a competitor's tile. They've done a really good job. This is the Mandalorian set for a green screen application. They've done a great job here. You can see these are lintel tiles, so a little different, but you can see some of that faceting effect as they make that curve. That's totally normal. And but I wanted to show you, if you're a rigging person, this is a pretty complex rigging system to create a ceiling of LED. So as we look at LED, if you're new to LED and you're thinking, hey, these should be easy, we just stick them on the ceiling. It doesn't quite work that way. I wish it did, but this is the kind of thing that it would take to suspend a full ceiling of that size over a curved application. I just use that as an example. So kudos to them. They did a great job on that. The frame alignment I mentioned is critical, but I also want to talk about something else. I want to talk about the actual modules themselves as they sit into the wall. What you're actually looking at here is you can see this ripple effect down this display. You're actually seeing the quadrants. Some quadrants are recessed, some are protruding. This is the Z-axis, the in and out axis. This is a critical element, as well as the X and Y. If the tiles are too close together at the seam will have a bright line in it. If the tiles are too close or too far apart at the seam, it will have a dark line in it. Now, we have seam compensation software that accommodates some of that, but it's impossible to remove everything if it's too far away or too close together. But also, that Z-axis is creating this other effect, which is not desirable at all. The module themselves, what you're looking at here, is a substrate, and then the module is on top of that substrate. The thickness of that module has a lot to do with the Z-axis issues you may face in installing a module or a LED tile. There is a lot of tolerance in some manufacturers in the lower price, more cost-effective, I would say, low-priced LED. Those tolerances are quite considerable, and they create a lot of issues on Z-axis. Again, you spend a lot of time trying to pull these modules in or push them out to try to get that Z-axis correct, and it is tedious work. So this is important to have this. Now, we have an automated process which ensures that all the thicknesses of the modules are exactly the same. But we haven't always had that. And if you've done a lot of LED installation, you're probably familiar with this in the sense that it creates a numbering system in the way that those tiles are actually installed. And the reason for that is because it's trying to take a tile here and make sure that the neighboring tile's module thickness are as close to it as possible. And that way there's a uniformity and you don't spend a lot of time adjusting Z-axis. And this is pretty typical. Now, I know certainly manufacturers are trying to move, and their R&D divisions move away from that and ensure that the Z-axis is perfect every time, and that really any tile can go anywhere on that display, and certainly that's what we've achieved. So that's important to know as you're installing that. The final thing I want to leave you with is really about resolution. For our home installations, our home TVs, certainly we want the highest resolution we can possibly get for all of the right reasons. There's nothing wrong with that, right? But what we're looking for in direct view LED in the application is really what we call the optimal viewing distance. The minimum viewing distance is when the 3 dyes actually merge into a single pixel. And the maximum reading distance is really based around the size of font and letters and what the human eye can see. And of course, that's a subjective because some folks see better than other folks. And so that's a little subjective. So what we look for at Barco is the optimal viewing distance. And this is when the eye can no longer distinguish between individual pixels. It's when you don't see the individual pixels and you see one perfect synchronized image. And the optimal viewing distance rule of thumb here, folks, is twice the pixel pitch in meters. So for example, a 1.5 pixel pitch would be 3. If you doubled it, it'd be 3 meters, and that, or around 10 feet. And that would be a good optimal viewing distance. It's a rule of thumb that we use. Why is that important? Because in the rush for higher resolution, in this application, you may say, oh, well, we're going to go the 0.9 millimeter. Of course, higher resolution is always better. But if the closest viewer to your display is 20 feet away, you're selling resolution that they don't need. Or worse, you could be speccing resolution that makes you non-competitive in a bid situation, because you're selling resolution that, because the price delta between a 0.9 and a 1.9, trust me, it's a significant price delta. And you veteran LED installers out there know that. So the price delta is considerably different, and you're overselling resolution that you don't need for the application. I think of like a lobby display where it's up high in the lobby, the closest person's 30 foot away. A 1.9 to 2.5 is perfectly fine for that. There's no reason to sell a 0.9 in most of those applications based on typical content. So that's, I throw that in as just a rule of thumb to help you kind of know what the optimal viewing distance for different pixel pitches are and how to do that. And in summation, really, it is about the things you don't see. The mechanics in particular, folks, is a complex, complicated element to LED. There are manufacturers that make mounts. We certainly make our own mounts for that, but there are tremendous third-party mount options out there as well that do a lot of the engineering and even some of the installation of the actual mounting systems as well. And they do a terrific job of it, no doubt. But trying to demystify the mechanical side of this, and when you take steel work and you're in somebody's MEPs and having those PE stamped, and it's a really important phase of LED, and we are carrying significant weight and heat. So it's important on the mechanics side to make that simple as possible. Also, the mechanics are critical because when you're installing LED modules, you can damage those modules. The higher the resolution an LED display is, take a 1.2 or a 0.9 millimeter, the higher the resolution, the easier it is to damage those diodes. You have to handle those modules with care as you're installing them. And imagine if the alignment isn't right, you'll get modules rubbing up against the modules next to it as you're trying to install it, creating edge damage and damaging diodes. So that's why the mechanics are crucial about how you install. And then ultimately, the programming is king. The processing and how we process image on LED is king, and it is critical to any LED. And it's important as you're looking at image processing to ensure that that image processing will stay on an evolution, a technology evolution or migration path with the actual LED tiles that you've chosen. So if you're a third-party processor working with the different tile manufacturers, you want to make sure that the drivers in the tiles will update and work with any future firmware. Those are critical parts of the processing issue. And so with that, I am finished. And I will look to Alina and see if we had any questions or anything we can answer.
Hello, thank you. Thank you very much for that, Todd. And I hope you guys enjoyed it. I do have a few questions that I see. I think there are some questions on the chat box as well, and then some on the Q&A, but I'll start with the Q&A. This question is from Mark. So would one of the best tests for processor power and sync would be to look at a star field in motion on screen? Also a moving image like an airplane to check for tearing. So I think you got the question right.
Yeah. Yeah, it's important. There's a lot of different applications, and certainly moving video is one of the easiest way to see that kind of situation, whether you're having banking issues, residual current. But the tearing issue is a pretty typical one where the image will actually tear in half. And that's a pretty typical one you see that is on larger displays. So it's when you're joining multiple processors on a large display format, you will tend to see some of that image tearing occur. So the best thing is on those large displays, if you, for example, if you walked in and there was a simple 4x4 full HD, it's using one processor, you aren't going to see image tearing per se on that. It's when we link those processors together that you start to see that.
Next question from William. Can you speak about LEDs embedded in a transparent film like LG's product? Is this a viable technology?
Yeah, unfortunately, I don't know much about that product. It's certainly interesting, and I've seen some transparent and some semi-transparent LED design. Most of the ones I've seen that with are low resolution, not high resolution. So I think it probably is a viable product, depending on the application, certainly. The semi-transparent that I've seen was probably a 4mm or an 8mm pixel pitch, and it was used for distance and think of like a airport lobby area where it was semi-transparent. You could see outside of the lobby to the outside, but it worked effectively, and it was fine for the content that they were showing on it. It worked perfectly. I think that technology will continue to evolve and get narrower and narrow pixel pitch, but I haven't had a lot of hands on, and I haven't seen that product, so apologies.
Okay. Next one, is there a soft copy of this information that can be circulated or accessed somewhere on Barco's website? You guys will receive a recording of this webinar, so you should be able to view it on demand as and when you would like to. Stefan asks, what is the typical lifespan of a LED wall?
That's a great question, Stefan. The typical life, right now, most manufacturers measure that in hours, just like you would on an LCD. One of the things, and this is just kind of industry term or jargon, we call it L50, or to half-life, or half brightness, not life. So we measure direct view LED by half brightness is when we measure that. For Barco's LED, it's 100,000 hours to L50, or half brightness, not to half-life or death necessarily, but it's really half brightness. So after 100,000 hours, all of those diodes on a display will be running at about 50% of the brightness levels as when they were new. It doesn't mean they're not usable, because keep in mind that brightness isn't always running at 100%. So that's if it was running at 100% brightness, full white, you would have about 100,000 hours to half brightness, or L50. Clearly, you're probably most likely not going to use it like that. And in that case, then that just, it extends the life to half brightness by that lower brightness and different content.
Bill Scroggins asks, do you have a required specification for how flat the wall is?
That's a great question. I'd have to check with our project group. I don't know if we do. It's a great question, though. It's something, Alina, we might check in and send him an answer to that. Yeah, one of the things that we spend a lot of time on our hardware is overcoming those wall deficiencies, because I was tongue-in-cheek when I said everyone has plumb walls. Of course, we all know we don't, and we all have to overcome that. I know that our current mounting system and some of the third-party mounting systems that we work with have really good Z and Y-axis adjustments to overcome those deficiencies. Where it gets a little difficult is if you're just using unistrut to attach to, you've got to shim that unistrut, and if the wall is considerably off, it's a lot of shims to get that mount perfectly plumb. But to that point, it's absolutely essential to have the steel work on the wall absolutely dead plumb.
Okay. Next one, any plans for a DCI compliant display?
That's a great question, and that's probably one for R&D. I know there's discussions for sure that have happened. Certainly, Barco is, you may know, is very strong in the cinema world, and certainly something that I think our R&D team looks at very closely. But I don't have, unfortunately, an answer to that. We could certainly poke around, Alina, and get a better answer to that. And yeah, and apologies, folks. Like I said, I sell LED and I work in the LED world, but I didn't invent it. So some of these I may not have answers to. And if I don't, we'll go get you the propeller heads that do know the answers.
Next question by Christopher Royce. If I wanted to use an LED wall as a background for a video set, what pixel pitch should I look for if the camera, Blackmagic Pocket Cinema, for example, is about 15 feet away? I want to avoid moire effect.
Mm-hmm. It's a great question. And with broadcast studios and green screening applications, so there's global shutter cameras, there's broadcast cameras, there's lensing in the broadcast world to reduce moire, and that's why we're more effective in the broadcast world, because the camera types are different than what they would use in movie production with the shutter, global shutter speed and refresh rate of a LED display. A lot of that comes down to the measurement of distance from the camera to the display, the angle the camera is at the display, and there's some measurements that have to be done in order to determine that, and with the camera that you're using as well as how that operates. I would say, just a rule of thumb, one of the most successful pixel pitches that we've had, we did the full Bloomberg broadcast studio in Dubai recently. That's all 1.5, and it tends to be that the 1.5 works pretty well in that application. I haven't specified any 0.9 or 1.2 in a broadcast yet, but that's typically what we lead with is a 1.5, and it's been very effective in that application in broadcast studio. If you would like some more information on that, please reach out to us. We can get you in touch with Jonas and some folks that do a lot of broadcast work to help you with that measurements and kind of that setup.
Okay, the next question is a really tough one. Not sure if you can answer it. This is from Ben Shipman. How did that guy get so smart and good looking? Thank you, Ben.
Yeah.
Let Todd's boss know about it. But I'm sure
Hey, Ben.
Yeah. Anyway, moving on to the next one, James Scott says, can I ask about a large video wall? If a tile fails, for instance, what is the ease of maintenance? Replacing modules, example. Can you just change the one, or would you need to remove the surrounding tiles to gain access?
Yeah, great question. So different manufacturers approach this differently. I'll talk to the way that Barco does, but I'm not trying to make this a Barco ad. Different manufacturers will manage this differently. When you have a full display that's built and you have one module that has an issue that needs to be removed, our software alerts you to the fault. And so what would happen is, in our case, you would take a new module, you take a magnet, hover it over the right corner of the defective module, and we have a motorized extraction tool that actually motorized by a motor extracts the module straight out, so it doesn't rub on the modules next to it or above it. That's critical because you'll get edge damage, and that's bad. So it will pull the module directly straight out from the wall. You unhook that module, you put the new module on, and you very gently press that new module back into place. You can do all of that in under a minute. And with our software, as soon as it detects that new module, it knows it's a new module, and it will auto-calibrate that new module to the existing display. There are other manufacturers that have something similar. Some don't, though. Some you'll have to get back in and rebalance that entire display. But all of our data is kept at the module level, not on a jump drive on someone's laptop, and that's how we do that. But other manufacturers, some are very sophisticated as well, and they do it well. Some, it's a manual process. Some will have like a suction cup device that you put on the module and you pop the module off. And some I believe there are other motorized ones as well, but we do the motorized one. It's a little more expensive, but that serviceability is crucial. And then also on service, it's important when you're looking at LED, not every application has rear access to a display, or some doesn't have front access because it's real high, so you have to get to it from behind. So as you're looking at LED manufacturers, make sure that they do front and rear access for service. That's important to accommodate whatever application you're doing it in.
Okay, next question. What special mounting considerations are taken for seismic sites? By Mark.
Yeah, well, all of our tiles have seismic cables that attach the actual modules to the frames, and the frame is obviously attached to the wall. There are requirements, strict requirements and OSHA requirements around that. I think most manufacturers have that down pretty well. It's aircraft grade cabling that that is hooked onto the module. So even if the frames are all mounted on a wall, let's say, and in a seismic event, if the modules were to fall out, that aircraft cable would keep those modules attached to those frames and not falling. So yeah, most manufacturers have addressed that.
Can you see tearing on a test pattern? Randy asks.
I don't think I've seen that on a test pattern. A test pattern, and if you're talking about like a static test pattern, I haven't seen image tearing. It's typically when we're doing full motion video where you'll see the tearing.
Okay, next question. What's the average distance from a wall for the heat with the tile shown? Sometimes we install a convention screen on a wall. Just asking.
Yeah, it varies from manufacturer to manufacturer by how much heat their tiles generate and where they dissipate their heat. Some tiles dissipate the majority of their heat from the front, so you can get them a little closer. There's a downside to that, though. If a majority of the heat's coming off the front of that display and you've got it in a room, that room gets pretty hot pretty quick. If you've ever walked up to an LED display and put your kind of hands in front of it and it's really hot, most of that heat's coming off the front. Most of the heat on our displays come off the back. And so if you're looking at a standard, it really depends on the size of the display. I mean, if you were doing like a 4x4, 5x5, you know, a 1/2 inch, 3/4 of an inch off would suffice to get airflow back behind that. Also keep in mind that you could easily put in some silent muffin fans behind that display underneath the trim of a mount and just blow nice cool air behind that display, get a little closer if you had to, or if you had an HVAC solution for that to make sure that air comes back behind that display would be good as well. So yeah, it really depends on the size of the display and the manufacturer and how they dissipate heat and how much heat they generate.
Okay, Ron asks, what are the typical layouts and spacing of the LEDs within a single pixel with reference to pixel pitch?
It varies on the types of dyes that are used. And I hope I'm understanding your question correctly. And if I don't answer it, please let us know and we can go get the answer. But when you've got a red, blue, and a green dye inside of a pixel, it depends on the kind of LED diode that you're using and the manufacturer of that diode and how they align that. So some may have the green in the center, some will green in the top, blue at the bottom. It depends on how they create that diode. Sometimes you'll hear a term called color shift. So let's say you have an LED display on the wall and you walk in and it's high on a wall and you walk in and you look up at it, you may see that the image is more blue. And that's because you're seeing less, because the angle you're looking at it, the diodes that you're seeing are overwhelmingly blue and not the green or the red maybe because it's the first diode in the sequence. So as you're looking up, part of the shader is, or the masking is covering the first diode and showing you more of the second and third diode. So that would be color shift, and that's what causes that for the human eye. But yeah, a lot of it depends on the manufacturer of the actual diodes and how they arrange those dyes inside of that. But really, the kinds of dyes that they're using inside of a diode really determines how small that diode can get. And that's the critical part of that.
Okay, next one from Jason. Can this product be retrofitted to a current rear projection setup, or would we need a whole new support steelwork for this one?
You know, that's a fantastic question. It really depends. It depends on what kind of steelwork you've got and what that looks like. The best way to find out, we work with a couple validated third-party mounting solutions. I know Draper, their foundation mount was designed using our tile, but Peerless and Premier make a tile or a mounting solution for our tile as well. I think that it's a great question. If you took off the rear project and you look at the steelwork you've got there, how could that be retrofitted, and how much steelwork would have to be added in order to get the tiles on? In our case, the tiles are 24.01 inches wide by 13.5 inches high. So it would have to fit within that. And that mounting structure would probably be, it could be based on different centers. So you may have to, on that steelwork, come across with new unistrut in order to mount that on. But I don't think you have to take everything out and throw it all away. I think you could probably add to your steelwork and make those LED tiles work effectively. You're on mute, Elena. Sorry.
I apologize. The next question is from Peter. Where would I check my region rep? Peter, what we'll do is we will have your question. We'll reach out to you if, on your email. The other way you can do it is you can also reach out to Todd if you have specific questions. But either way, we'll make sure that you're taken care of. Next question from Alan. What do you recommend for processing if it is not a standard resolution, like a 1920 by 1080 or a 3840 by 2160? What will the image look like if it is scaled to fit a custom resolution?
Yeah, it's a great question. So the way that our processors and other processors work is you can do some scaling in our processor to match the canvas size. So one thing that is a bit of a confusing point, and it may not be for you, but for others, it's a bit of a confusing point, is they look at our LED processors and they'll see an HDMI input and immediately sometimes you draw a correlation as sort of a matrix switch, like how many sources could I put into that box and show on the display? But that's not how LED processors work. That's what we would say is upstream signal manipulation, upstream from that. The processors have one job. Let's say you've got 4 processors on a relatively large display. Each of those processors has one HDMI input. You'll take 4 HDMI inputs of the same source and put it into those processors. Those processors then will work in conjunction with each other to deliver the target output resolution. Okay, so if the target output resolution is a custom resolution size, those 4 processors will take 4 HDMI inputs, standard, HD inputs, and it will actually process and deliver the target output resolution. If you need custom resolution upstream in our world, then we would lead with one of our image processing products, which are stunning, the E2, the S3, the PDS 4K, and then you can do anything you want as far as inputs. If you've got really wonky inputs, resolution inputs that you need to feed to that wall, you put an S3 in front of our display or an E2, solved. It'll take whatever input you're doing, it will deliver the LED processors what they want, and then the LED processors will deliver the exact target resolution output of the display. So just treat that entire display as a canvas, if you will.
Okay. Steve Sugg asks, can you elaborate on how image scaling works with video controllers like the planar VCR-L? For example, many video walls have non-standard aspect ratios. How do these controllers accommodate for that?
Yeah, which is basically what I was just explaining effectively. It's multiple processors working with multiple HDMI inputs, standard HD or 4K or 8K inputs, and then all those processors work to blend those images and deliver a target output resolution, which is what the display is. And that does that in those processors, those LED processors. All of that happens in those processors. So, and I'm not familiar with planars. I haven't worked with that. Obviously, I'm a Barco person. They probably wouldn't want me putting my hands on their products. But I think that, yeah, very similar in what's trying to be achieved there is delivering the target output. And that's, I know I'm probably making that relatively rudimentary for video experts, but it's the simplest way I can think to explain that the LED processors are not true signal processors like you would have upstream. Let's say like a multi-source, multi-window device, whether it was an Extron or Crestron or Kramer or whatever it might be. That's all done by matrix switches and content source control upstream. The LED processors really have one job, and that's to take multiple inputs to deliver the target resolution output.
Okay, next question. I'm not sure there's a straight up ask here, but I'll still read it out and see if you can answer. This is from John Bishop. HDR content handling, SDR, HDR switching, PQ values for various mastering levels, a P3 color space reset, and then question mark.
Yeah. So P3, our current systems achieve P3 Rec 709. We're getting ready to release a new evolution of our processors, which are HDR DCI compliant. We are in a 4K, 8K box, and we're moving towards that. So for sure, an SDI input and those kind of things. So keep your eye out for that evolution of that. There are other processors out there certainly that take those kind of inputs. I believe Brompton has one that does that as well. So there's some nice processors and even third-party processors out there that do that. So all of those formats and those achievable. We're actually going beyond Rec 709 to Rec 2020 and beyond. So we're going to have an incredibly wide color gamut for the evolution in Finipix. So everyone's moving in that trajectory.
Okay, Jivan asks, is chip on board going to be a standard for the very high resolutions display?
Yeah, and I think this is probably the last question, Lena. We only have a minute or so left. Yes, chip on board, great technology. Some manufacturers were early to the market and with chip on board. They're excited about it, and then realized there's some challenges with chip on board. It's a great technology, and yes, they're basically, those diodes are just pinned directly onto the board, the main circuit board, and it's a great technology. But there's some challenges around chip on board manufacturing, tolerance levels, sustainability issues. If one diode goes out on a board, is the whole board then defective because you can't really replace the diodes? There's some things to consider with chip on board that don't discount it as the technology that LED is moving to, but it does at least make you want to step back, measure twice, and cut once. Certainly, we're looking at mini and micro LED and chip on board, and I think in answer to your query, to make a long story longer, I do believe chip on board is where most manufacturers are looking for the next evolution of LED technology.
So we are at 1:59, but I've easily more than 20 questions left. So we can definitely do, I think what we will do is we have all these questions captured. So for each one of you that we could not get to you right now, we promise each one of you will have an answer that will reach out to you individually with the answers. Give us a couple of days so that we have your information, and then we are able to draft out that information. And then if there are follow-up questions you have, you can always come back to us. But we would definitely make sure that each one of your question is answered. So, but thanks a lot for that. This has been super engaging. This is actually the first one in a two-part series. Our next webinar on this topic, which will cover a little bit about chip on board and evolution of LED technology as well, it's scheduled, the next one is scheduled for April 22nd. So we definitely hope to see you all again on that webinar. You'll get more details very soon in the next few days. But again, coming back to the questions, I want to make sure that you guys are get it, that we will answer the questions. I apologize that I mean, it's an exciting topic, so I'm very happy we had so many, but we'll make sure that each one of you is taken care of. Okay, so thank you very much and have a great day.
Thank you, Todd and Alina. And I want to thank everyone for attending today's webinar, LED Video Walls, the invisible mechanics that bring your picture into view. This recording will be available on avixa.org/webinars within about 5 to 7 business days, and your one renewal unit will be applied to your transcripts within those 7 days. If you have any trouble, please contact my team at webinars@avixa.org. Just a side note for CTS holders, if you've registered for the webinar with an email address other than what we have on file for you, you won't get credit for attending it live. We can correct it on the back end. However, just to email your account rep, whoever that may be, and let them know they use the wrong email address, and we'll get it fixed on the back end. So I just want to take time out to thank today's sponsor, Barco, and a huge thank you to our presenters, Todd and Alina, for helping us to understand LED video walls. And also, please be on the lookout for part 2 of this airing at April 22nd at 1 p.m. Eastern. We hope you've enjoyed this. Please stay safe, everyone, and make it a great day.